Going to solve the numerical problem related to the motion of the body and the force applied on the body. For this, let's take question number 21. Till 20 we have done in previous classes. Calculate the force required to produce an acceleration of 5 meter per second square on a mass of 0.5 kilogram. Two physical quantities are given. Number first is acceleration is 5 meter per second square. Acceleration is given, it is 5 meter per second square, and mass 0.5 kg. Mass is given, it is 0.5 kilogram. Now, using an equation, F is equal to ma, force equal to mass into acceleration, we can calculate. Mass is given 0.5 kilogram, acceleration 5 meter per second square, 5 5s are 25. Now point comes in between 2.5 and kg meter per second square is Newton. This way we can solve the numerical problem 21 very easily. It was very easy. Now the number 22, let's talk about this. This is a little different than other numerical. A force x for 0.2 second on a body at rest of mass 4.8 kg. The force is then ceases. The body then moves through a distance of 5 meter in next 2 seconds. Calculate this. This seems to be a little different. That's why I want to show it with diagram. You don't have to show with diagram in examination, but for your convenience only, to make you very clear only, I want to solve this with the help of a diagram. Look at this. Let's say this is the direction of the motion of the body. This is a body and force is applied on this body, and what is told, the mass of the body is given 4.8 kilogram. Mass of the body is given 4.8 kg. And what are other questions? The force acts up to 0.2 second. Force is acting on the body up to 0.2 second, and let's say after 0.2 second the body comes to this position, and the body was initially at rest. It means initial velocity is 0. Now what are other information? The force is then ceases. The body then moves through a distance of 5 meter in next 2 seconds. Let's say for next 2 seconds it is moving, this time 2 seconds, and it covers 5 meter distance. Distinctly we have two cases, number 1 and number 2. In case number 1, force is applied. That's why the body accelerates. Every second its velocity goes on increasing. This is the time period of acceleration. And when force is ceased, then the body doesn't accelerate. We must have clear idea about this. When force is not applied on the body, then the body moves with the constant velocity. What velocity it had gained at this point, it moves with the same velocity. Okay, this is the second case, and this is the phase of constant velocity. This is the phase of what? Acceleration. Okay, now let's go further. Question number 1, 2, 3. The velocity gained by the body. Here, question is velocity. How much is the velocity gained by the body is first question. Now, number 2 is acceleration produced by the force. Number 2 is acceleration. How much is the acceleration? And number 3 is the magnitude of the force. It means force is asked in the question. Okay, now I don't have to see this. We don't have to see this. This sentence is written in the numerical problem. This information is enough to calculate. Okay, now what is the question first? V means what? Velocity at this place, or with the same velocity it keeps on moving, velocity at this place, whatever it is. Now this can be calculated very easily. We don't have to use this equation because here 5 meter distance is covered in 2 second time. That's why normally we know that velocity equal to distance by time, and this is equal to here 5 meter and time is what? 2 second. If 5 is divided by 2, we will have 2.5 meter per second. This is velocity gained by the body. Now Acceleration, how to calculate this acceleration? For acceleration, we are using this one of these equation, but mass is not present here, so we are using other sources. Here every equation has got four quantities. Three of them should be given and fourth can be calculated. Here we have u, t, and final velocity v we have calculated u, t, v, and we have to calculate a. U, t, v, a. Which equation contains this? The u, t, v, a. First equation. That's why using this a equal to v minus u by t, we can calculate this acceleration. Final velocity is how much? 2.5 meter per second, and initial velocity is what? 0. And here it is time. What is the time taken by the body? 2 seconds, and 0.2 second. This is equal to 2.5 meter per second upon 0.2 second. If we shift this point to one digit right hand side, in both the cases the quantities become equal. 25 divided by 2 meter per second, and this second is in also denominator, that's why unit is meter per second square. And if we divide 25 by 2, then 12.5 comes. 12.5 meter per second square is the acceleration gained by this body due to this force. It's clear. Now force we have to calculate. Now how can we calculate force? Force can be calculated easily. Force equal to mass into acceleration. How much is the mass? 4.8 kilogram is the mass. And what is the value of acceleration? 12.5 meter per second square. If we multiply 4.8 with 12.5, then its result will be 60. I have calculated previously, therefore F is equal to 60 kg meter per second square means Newton. This is the solution of question number 22. Now I want to tell you a little more. These numerical are a little different than what I taught in previous class. Now let's go through another question. Question number 23. What is here? 23. A cricket ball of mass 100 gram moving with a speed of this much. Okay. Question number 23. Mass of cricket ball is 100 gram. And we are using SI system, that's why 100 gram can be converted into kilogram by dividing it with 1000. This is 0.1 kilogram. Okay. Now it is moving with the speed of this much. It means initial velocity is 30 meter per second. Initial velocity u is equal to 30 meter per second. Other information is brought to rest. If it is brought to rest, it means final velocity is equal to 0. Brought to rest by a player in this much second, it means the player is taking catch. The player brought it to rest, and the time taken by him to stop it is 0.03 second. Now calculate 1 and 2. There are two questions. Number 1, what is the question? Number 1 is the change of momentum. Number 1 is change of momentum. Let's calculate first the change of momentum. Okay, what is the momentum? If you remember, momentum is the product of mass and velocity. Is the product of mass and velocity, m and v. And change of momentum means what? Final momentum minus initial momentum. And final momentum means m into v. Mass into final velocity is final momentum, minus initial momentum means mass into initial velocity. Final momentum minus initial momentum gives what? Change of momentum. Now mass is 0.1 kg. 0.1 kg into velocity, final velocity is 0, minus again mass is 0.1 kg into initial velocity is how much? This is 30. And this is equal to 0 multiplied by this becomes 0. It doesn't have any meaning. Minus 0.1 into 30 is 3. Now, what the unit of momentum? Mass is measured in kilogram, velocity is measured in meter per second. That's why kg per second. This is the change of momentum calculated. Now let's go to second point. What is asked in question number 2? The average force applied by the player. Average force applied by the player. It means force applied by the player. For force, we need to use F equal to ma. M is given, but A is missing. That's why first we have to calculate A. How can we calculate A? By using these equations. One of these equations. U we have, T we have, V we have, and UBTA. Using UBTA, the same equation we are using here, A equal to V minus U by T. And this is equal to V0 minus U is what? U is 30 and T is time taken is 0.03. Okay, this is equal to minus 30 upon 0.03, and this is equal to here we have decimal point. If it is shifted to 2-digit right hand side, then we can use 20 on the numerator like this, and then can be shifted. This is divided by 3. Okay, 3 1s are 3, 3 1s are 3, 1000. This is the answer. What acceleration is minus 1000. Unit of acceleration is meter per second square. Okay, now finally we are calculating force required to stop that cricket ball. F is equal to ma. Mass is given here 0.1 kg, and acceleration we know just now calculated, it is minus 1000 meter per second square. Now multiplying this to point, if multiply this, minus remains same, minus 100 kg meter per second square is Newton. This is the force used by the player to stop that moving cricket ball. Now have you noticed that momentum came in negative value, and here acceleration also came in negative value, and force is also in negative. What is the reason? Momentum, acceleration, force, all these three are vector quantity. Vector quantity may have negative value also, or it may have positive value also, it may be zero also, but a scalar quantity never be negative, never be zero. It has always positive value, but they are vector quantity. That's why they came in negative. This change of momentum came in negative. It means the momentum is in the opposite direction to the motion of the body, and acceleration also negative. It means retardation. The force is applied against the motion of the body, and this force is also negative because it is acting against the direction of the motion of the body. Okay, this much for today.